Hello dear student, Unit 1 completed. Today I would like to start Unit 2. First result of Unit 2. State in solve Caloret's differential equation. C is a special type of equation solvable for y. And the equation of the form y is equal to px plus f of p, where p is equal to dy by dx, is called Clairaut's differential equation. Clear? It is solvable for y. Here y is equal to px plus f of p is solvable for y, therefore differentiate with respect to x. What we get? Dy by dx is equal to p plus x dp by dx plus f dash p into dp by dx. It is easy to differentiate it. Therefore p is equal to p plus x plus f dash p into dp by dx, and therefore x plus f dash p into dp by dx is equal to 0, and hence dp by dx is equal to 0. Says equation number 1, and therefore what we get? P is equal to C, where C is arbitrary constant, or say equation number 2. Therefore by 1 and 2, what we get? Y is equal to cx plus f of c, and is a solution of equation 1. Very easy. Is a Caloret's differential equation. Clear? Now see here, second result of this unit, state and prove. State and solve Lagrange differential equation. An equation of the form. Of course, that is also particularly solvable for y. Y is equal to x into f of p plus capital F of p, where p is equal to dy by dx, is called Lagrange's differential equation. Called Lagrange's differential equation. Clear? Now see here. Lagrange's differential equation is also known as Caloret's differential equation. For particular case, put that as a note. If f of p is equal to p, then it is Caloret's differential equation. Is a particular case. So every every colorless differential equation is also Lagrange differential equation also. Clear? Both are same. In particular, for this case, f of p is equal to p. This one is not. And that thing we are going to use in a practical section, so don't worry. Now see here. Say is equation number 1. It is solvable for a y. Here y is equal to f of p plus f of p. Say equation number 1. Differentiate with respect to x on both sides. So what we get, p is equal to f of p plus x f dash p dp by dx plus capital F dash p into dp by dx. So take p minus f of p on left hand side, x f dash p plus capital F dash p into take dp by dx common. Clear? This is the case. Now from this one, what is dx by dp? Is nothing but x f dash p plus capital F dash p over p minus f of p. Clear? Now dx by dp minus f dash p into p minus f of p into x. Take this part on left hand side, rest of part on right hand side. F dash p over p minus f of p. This one is of the form dx by dp plus some function, let us call g of p into x is equal to h of p, where g of p is in terms of p and hp is nothing but f dash p over p minus f of p. Now is equal equation number 2. Equation number 2 is linear in x, and so it is easy to solve linear differential equation. How to solve it? See, and its solution is which one? X into if is equal to q into if into dp plus c, and therefore x into some function of p. Let us consider capital G of p, on right hand side capital H of p plus c. So x is nothing but h of p over g of p plus c over g of p. Clear? Now taking say 3, taking value of x in 1, we have y is equal to some function h of p over g of p plus c into g of p into p, f of p plus capital F of p. Call equation number 4. Therefore, equation 3 and 4 is parametric solution of given differential equation and is a colorless form. Also we know that is some part of that thing is in that form. Now see, let us consider some simple example based on Caloret's form. Now see here. First example number 1. Solve y is equal to xp plus p cube plus log p plus sin p. Here, given differential equation is of the form y is equal to px plus f of p and is Caloret's differential equation. Caloret's differential equation, and therefore taking p is equal to c, we have solution y is equal to cx plus c cube plus log c plus sin c. Clear? Now this is the way to see that thing. Some of examples are of that form. See here. Second one, p cube plus px minus y is equal to 0. So y is equal to px plus f cube. That is also in that form. So its solution is c cube plus cx minus y is equal to 0. Clear? Also, consider example y is equal to px plus p into 1 plus p square. That is also Caloret's form. So its solution is y is equal to cx plus c into 1 plus c square. I am leaving for you, huh? Second sum. Yp is equal to xp square xp square plus alpha. So this implies y is equal to px plus alpha by p. So it's Caloret's form. So y is equal to cx plus alpha by c. Next example, y minus px whole square is equal to 4p. So y minus px is equal to 2 root p. And therefore y is equal to px plus 2 root p. So once again it's Caloret's form. So our solution is y is equal to cx plus 2 root c. Yes or no? Yes. Or we can put in that form also. Y minus cx is equal to 2 root c, or y minus cx whole square is equal to 4c also. Clear? Now this is the way to solve out it. Clear? Now rest of sums are there based on that thing, but that we are going to see in practical section. This is the initial starting of unit number 2. Unit 1 we already completed. Today we already seen 2 results and some example based on Caloret's form. See, today only I am making small video to see the revise this to theory section. In next video lecture we are going to see the practical based on Lagrange differential equation. Thank you.